would like to welcome Alex Bernberg to DefCamp 2021. Hi, Alex.
Hello.
Welcome.
Hello.
Just to give you a quick intro and to let you know who Alex is and what he's here to talk to us about, in case you haven't checked out his schedule before. So Alex is a security researcher and CEO of Zimo Security. He spends a lot of time, energy, resources, and know-how in finding vulnerabilities, and find vulnerabilities he did. So in 2021, they did an application security assessment on SolarWinds Orion, which we all know by now and is still kind of echoing throughout the industry and beyond, and found 4 critical vulnerabilities that then you ethically disclosed. So now we're about to hear the story behind that. Thanks so much for being here with us, Alex. I'm looking forward to it.
All right, so today I'll be presenting to you 4 0 days that we discovered in the SolarWinds Orion platform that when chained together can be used to obtain unauthenticated remote code execution and unauthenticated file read on the target server. But before I get into the technical details, I would first like to shortly introduce myself. So my name is Alex Bernberg. I'm a security researcher. I mostly deal with vulnerability research and exploit development. And I also founded Zimo Security and the CEO with where we also do about the same stuff. So vulnerability research and exploit development. But let's get into the presentation. So the first question then we should ask ourselves is why target SolarWinds? Well, it may seem obvious that it was already targeted in a sunburst incident, so we may already have interest in it, since we would like to know if the security got better or if it's still the same. So that is a very good reason. But what I think is better is to see why SolarWinds was targeted in the first place. So this chart was taken from 2016. Where SolarWinds had the highest market share of network management software. Right now, I don't think it's the highest, but it's along the highest market shares. This software is used primarily in government and corporate institutions. So these are the primary targets of most attackers these days. Right, and besides all this, so besides the fact that it's widespread, it's a widespread software, it's also business critical. So what we will get to understand about what this software does is that it is used primarily for network and system management, but actually the SolarWinds vendor has released quite a few others. Quite a few other software. For example, they do patch management, they do quite a lot of stuff. So yeah, thing that usually this software not only controls one server, but since it's monitoring the network, it also controls all the endpoints that it's monitoring, because the purpose of this software is to see if there is any failure in the network. So for an attacker, this would be very useful to have control over this software, right? Because from there we can get control over pretty much any endpoint. So let's see more about the products, right? So I was saying that there is a network monitoring, so there are network performance monitor product, but the most popular product is the server and application monitor, which pretty much does detects failures in networks. But they also have quite a lot of other interesting products. For example, they do patch management. They do quite a lot of stuff. And at the foundation of all this lies the Orion platform. So you can think as a basis for all of their software. Right, so each of their software, it's somewhat of a specialized extension of it. So the Orion platform deals with quite rudimentary functionality. So let's see more about the Orion platform architecture. The Orion platform architecture mostly consists of alerting and reporting functionality. Today we will take a look a lot more at the alerting functionality, but this Orion platform stands at the core of each one of these products. So finding a vulnerability in the Orion platform would also mean that we have the same vulnerability in all of their products. So that's what actually ended up happening. But yeah, more on this later. So about the server and application monitor, this is how the web console looks. So this gives us a viewpoint to all the endpoints connected to it. So for example, on the left, we could see that there are quite a few endpoints connected. This is a demo screenshot. But in this demo application, we can see that there are, for example, Apache or App Inside. But we can also see that where there are failures or warnings, we can see them on the screen. So I hope you can kind of get a feeling of what the purpose of this application is. But yeah, we can get a lot of insight into what is going on Target network. All right, so let's take a look at how this software is organized. So a very good point to see first is what kind of privileges do users have, because there will be quite a lot of users in this software. For example, there will be sysadmins, there will be complete administrators, but there may also be good guests. Well, all of these users have quite a few permissions. Our interest is in the alert management permission that allows us to add, edit, and delete alerts. But what this actually means is that the sysadmins are permitted to configure, okay, well, if this goes wrong, we want to be alerted in this way. So it gives them the power to do that, but it doesn't give them much more. So they don't have much more control over the server besides that fact. And also there is a guest user. So thing to point out here is that if you have a low privilege RCE in the Orion platform, you may use the guest user because it's installed there by default, but sometimes, well, by default also it's not enabled. But if you are lucky, you can get enough RCE through your low privilege RCE. So let's see about the previous research. So we know from the Sunburst incident that, well, we don't exactly know how it happened, but we know that during that time, there were two vulnerabilities that were chained together to obtain unauthenticated remote code execution. So the cross-site scripting, for which there are known public details, and the command injection and the execution of arbitrary VBScript. This has been analyzed by the ZDI. And also, a lot of reports came from the ZDI that target this attack surface that I will be talking about. So like, for example, the SQL injection is targeting this. And also they did some more analysis, but more on this later. What we will be focusing on is the same attack surface that has been hit by by one of the vulnerabilities from the Sunburst incident and by quite a few others from the ZDI. So about our work, well, we found the email web page command injection and the export to PDF command arbitrary file read. We found this in the same attack surface that the previous two vulnerabilities that I told you. So like the the second from Sunburst and the SQL injection. This was found in the same attack surface, and we collaborated with FireEye to make sure that organizations are protected before the patch is released. But we also found two others. Well, the reflected cross-site scripting is quite basic, and the key to our chain was the improper access control. But yeah, I will talk about this shortly. So let's see about the reflected cross-site scripting. So as I was saying, this vulnerability is quite basic. So we can just see it takes the query parameter from the title query parameter from the GET request, and if it's not there, it just defaults to an alternative. But yeah, it just takes the query parameter. It says the title to it, and no HTML escaping whatsoever. No, like not any kind of escaping. So again, quite basic. Why did this happen? But a payload for it would be the following. The resource query parameter is needed because there is a check for it. If the query parameter is the resource query parameter is not there, the exploit will fail. So what we did with the title is we just close the title tag and we open the script tag and we just injected our payload there. So yeah, this could have been done in more like in better ways that would not be that obvious. But for a proof of concept, this is enough, I would say. All right, so what capabilities do we have so far? So we can bypass authentication. Obviously, we can impersonate users since we have the cross-site scripting. We can also bypass firewalls, which I think this is quite an interesting point to make. Since we are not directly connecting to the SolarWinds server, and most often these are not directly exposed to the internet, we can deliver the exploit through different ways. So, for example, we can deliver an email to the sysadmin with the exploit embedded in it, and yeah, when the sysadmin clicks, the exploit triggers. But well, a pretty hard limitation is that it requires user interaction. So, like, this limitation is quite bad, but I think that because of the outcome, I think it's worth it. But yeah, let's see more on the alerts. So I was talking previously about the attack surface, about alerts and the alert management permission. So why do we need this? So, well, the purpose of this software is to alert the user if something goes wrong, right? So what alerts do is when a condition or multiple conditions are true, our programmable action is triggered. So the SolarWinds Orion platform constantly polls if that condition is true, and if that's the case, it triggers our actions. Yeah, so like we can also see the definition that the vendor gave, like if it gives an automated notification that event has occurred. So yeah, we can see also an example of what does this mean, like when a component goes down, or, yeah, when an application goes down. So let's get to see first the conditions, right? So what are conditions? Well, in order for the action to be triggered, we need to set some form of condition. So most commonly, this is used to like a monitoring condition. Did this server, this IP go down at any point in time? Well, if it's down for more than 5 minutes, trigger the action. But what we actually need is for the condition to evaluate to true, because the attack surface is in the action that will be triggered. So we need to be able to trigger the action constantly. So about the actions. So this is an action that has a user-defined configuration that triggers when the condition is true. And yeah, we can see here that there are quite a few actions. If you look in the software, you'll find quite a few more actions. So this is quite a wide attack surface. So in our case, we use the email a web page action to obtain RCE. But yeah, in the sunburst, the ones right below it, the execute external program and execute external VBScript were used. But yeah, these actions are quite a good attack surface for the SolarWinds Orion platform. So about the action, we can also trigger it programmatically. So what this means is that we can make a post request to the API action test endpoint, and we can give it, like, we can give quite a few user-controlled parameters. So when thinking of the action configuration, most of it we can control. So like, we can control quite a few parameters that, in my opinion, shouldn't really be let to be controlled. But in this example, we can see that this is just a simple action that will set the property with a certain name to a certain value. But yeah, through this functionality, we can trigger all the other actions too. So like our exploit can be triggered through this functionality, and the ones used in Sunburst can be triggered through the same functionality. So let's get a bit into the Sunburst vulnerability first. So the Sunburst vulnerability are actually two in two of the actions, but they don't differ that much. So this just executes a VBScript from a network path on the SolarWinds Orion platform server. But what this means is that, so yeah, we can execute scripts, but we are not administrators. Like this is a problem because we only need the alert management permissions to do this. So this capability should be only reserved at most for the administrators. Hopefully, not even a user with administrator permissions would be able to do this. But yeah, in that case, you could see why it would be possible to execute commands, but not really from the alert management. Alert management is not for that. But about this RCE, there has been another one patched under the same CVE. So like the action next to it was execute an external program. So these are quite similar. The other one was executing a VBScript, and yeah, it just again goes to our remote SMB share and executes the program. So about the action functionality, there was also SQL injection that was reported through the CDI. So in the body to post, in the user configuration of the action, we were able to insert macros and execute whatever SQL query we wanted. So in this example, we are selecting the password hash from the database. But what we can also do is we can update this password hash to value known. So through this way, by updating the password hash, we are able to hijack the administrator account. And about our vulnerability, the first one is the file read information disclosure. So each one of these actions has a method in its class that is execute internal. This method is called whenever the action is triggered. So this is the entry point of the action. Everything that the action does starts from here. So we can see that in this case, our configuration is loaded at point 1, and what happens here is that we give it our configuration, and this action goes to a remote HTTP server that we control, and converts the HTML of that the server serves. It converts it to PDF, then it emails it back to email that we control. So how did we exploit this? Well, first, we can see that we can set quite a few parameters. So again, we can set the web page URL. We can we will be able to modify the SMTP configuration, but this allows us, and this gives us a lot of leverage over what we can do with this. So what ended up happening is that this action uses external PDF converter. So the PDF converter is in another binary that what it does, it just goes to the remote server and converts the file to PDF, and it adds it as an attachment. And the problem here is that we can also reference local files. So here the arguments for the PDF converter are created, and the PDF converter is run at point 5. And how can we use this? We can use this by, for example, we can point an iframe to a local file on the server. And by this, since we control everything about the web page, we can leak pretty much any text file through the iframe. We do need control over the SMTP configuration, but more on this later. And yeah, this allows us to exfiltrate files from the target server to our SMTP server. So the capabilities that we have so far is that we can leak arbitrary files. We had a limitation that we required user credentials with alert management permission, but since we already have the cross-site scripting, we don't really need that anymore. But we also have a requirement. We require that we control the SMTP server configuration, because in order to exfiltrate the data, not only we need some entry in the SMTP configuration, but we also need the entry to point to our server, because if not, it won't end up where we need to. So we won't be able to successfully leak the file if we if the files doesn't end up to our server. But also within this this same action, we discovered also command injection. So when the conversion takes place, the arguments are generated from the URL that we provide and from a file path that we don't really control, but this is done in an unsafe way. So when we take a look at the format, we only control the arguments. We don't control what we can, what program can we execute. So this is not really that straightforward. We cannot say execute command prompt with our command. We can only execute the PDF converter. And what we can do is we can inject some more arguments in the URL parameter. Since the URL parameter is never actually checked that it's an URL, we can also inject, for example, an output file parameter, and we can control that to point to our shell. So when the PDF is converted, instead of how it's set to be converted to a temporary file, and later that file is deleted, we output the PDF to control locations. For example, our backdoor is in shell.aspx. So yeah, we have one problem though. Our problem is that we are outputting a PDF. So by this doesn't mean that we can just put our shell on the HTTP server, and when it gets converted to PDF, the HTML will just show up, and we will be able to just go to shell.aspx and get RCE. It's not that fast. The regular text that is found on the web page is encoded in the PDF, so this breaks our shell. We cannot directly obtain remote code execution through this path. But what we can do is we can use images. Fun fact: actually, images are not encoded in the PDF. So we can just embed an image in the with our payload in the EXIF section of the image. And since this is not encoded, this will remain the same. This will remain the same in the PDF that is converted, thus allowing us to get a clean shell and execute arbitrary commands. So we also place this chameleon is actually the proof of concept. We place this chameleon at the top of the page in the hopes that it will show up earlier in the PDF. We actually need it to show as earliest as possible, because any kind of other character will or might possibly break the shell and will break our exploit. But this usually doesn't happen, so RCE can now easily be achieved. And what do we have so far? So far, so good. We can execute arbitrary commands. Again, we don't really require user credentials, but we require control over the SMTP configuration. Again, the difference between the file read and the command injection is that the file read requires us to be able to control what entries are in the SMTP configuration. This vulnerability doesn't. This vulnerability only requires the target server to have some kind of SMTP configuration in place. So this is this would be a common instance of the software. So this could happen commonly in the wild, since sysadmins require to be notified about what is happening in the network. So this we might actually see it in the wild, the fire reads, without the next vulnerability, not so much. So the SMTP configuration, what do we use it for? Well, we use it for mostly to help the sysadmins get notified about what is happening. So how I said previously, but in this case, we are using it to send a PDF of a web page. For example, in the case where, let's say, a server breaks that we are monitoring, this software will just go out to the server, see, okay, well, it shows error status code 500 with this error. So send that to the sysadmin, and yeah, he will hopefully know what to do. So the SMTP configuration is primarily needed by the alerts, but the servers may only be added by an administrator. And well, we might be able to get control over an account with alert management privileges, so a sysadmin, but we most likely won't be able to get control over an account with administrator. So we need to handle this. We need to find a way in which we can add entries to the SMTP server configuration. So the next vulnerability is the final piece of the puzzle. So only privileged users are allowed to import alerts. That we know. But as you can see in this case, if the import SMTP server is set, we can also import SMTP server configuration, which is what we need. So this is so far so good. Since only privileged users are allowed to import alerts, if you don't have the privilege, well, what it should have happened is if you don't have the privilege, you are not able to call this functionality. But that is not the case. What ended up happening is that the privilege that you can import alerts is checked only at the end. So the alert is created, and if only if the user doesn't have the correct permissions, the alert is deleted. But well, this is an alternative way of doing things, and would be good as long as it doesn't have side effects, which unfortunately it did. So what I showed you earlier about the fact that we are able to import SMTP servers on the Orion platform. Well, we can do this, and the configuration will stay there. Will stay there, even though the alert is deleted, because they are stored in separate places. So if a low privilege user ends up doing that, they will only be able to import to insert entries in the SMTP server configuration, because their alert will be deleted. So this is good. This is what we needed. We are able now to change the configuration from a low privilege user, and the SMTP entries that we inserted are never checked. So there is nothing in place that would delete them. So we can see here in SWQL Studio that our SMTP server is inserted in the database, and yeah, in this case, it is not set to the default server, and it is not enabled. But we can also control those parameters. So we can also add a server that is default, right? And we don't actually need it to be the default. but would be quite useful in other attack scenarios. In our case, since we can select what server we can use in the alert configuration, we can just select the server by the SMTP server ID, and everything will work fine. So we don't really need to bother about the fact that it is or is not default. So what capabilities do we have so far? Well, we can insert new SMTP server records, which is what we needed. We don't require user credentials since we have the XSS. And yeah, this is the final piece of the puzzle. We can do what we want. We can obtain remote code execution on the server by chaining all this. So about the chaining, putting all these vulnerabilities together, what we need to do is to get the target to click our malicious link. We need to add the configuration, the SMTP server configuration, and then we can just get RCE through the PDF shell, and then we can enjoy our shell. Well, we didn't really end up using the fire read. I just thought it was a cool vulnerability to include, since it had the same attack flow. But yeah, it didn't render useful. So on how the attack flow is happening. So again, we just send a malicious link to the victim. We trigger the XSS. We modify the configuration. We trigger the action. All this is happening from the victim's browser, nevertheless. So we don't do anything from the attacker machine. And after that, the SolarWinds Orion platform server will go to our server. We'll take the HTML, convert it to PDF. It will then send the shell, and after that, our shell will be written to disk on the SolarWinds. We use the SAML login.aspx location because we needed a place for our shell that was unauthenticated, so we actually can make use of our authenticated RCE. And after that, the response is sent to the victim, and we can execute commands via our shell. Well, we can also execute commands via the shell from the victim side, but it's just faster this way. So yeah, it's just a preference choice, and I would say not much else. So let's see a demo. So what is happening here is that I'm copying the XSS to the victim browser. While this is happening, I also set an iframe to the default web page, so nothing looks that sketchy. We are delivering the stager, so the JavaScript exploit. We are delivering it to the user browser right now. We are installing the SMTP configuration entry, and after the SMTP configuration entry is installed, we are overwriting the SAML login. So yeah, it should happen anytime.
Alex,
all right.
I was
yes.
Cool. I was just under the impression that you froze. I wasn't sure.
Oh no! I was just waiting for the shell to pop. All right. So yeah, we can see that our backdoor is installed at sml.aspx location. We also have I also made a backdoor to have a password, so only us can execute commands on the target server. So let's do that. So right now we are yeah, we executed a calculator, and we are executing Notepad. And yeah, we can see this in Process Explorer. So we managed to use our backdoor to execute whatever code we want. So conclusion over all this, I would say that SolarWinds is still a good target, but their security is improving, and is improving considerably. Quite a few very good reports came from the ZDI, and I would say that their security posture and the way that they handle this kind of incidents is quite good. So personally, I had a good experience reporting these vulnerabilities to them. But as an attacker, if you are interested to target SolarWinds products, go for Orion platform first. If you find anything in it, you will get the same vulnerability in all of the products. So your vulnerability will be much more impactful if you get it in the Orion platform. And on top of all this, I think there is a lot of unexplored attack surface. So in a previous slide, I showed the SWQL Studio. So what that is a custom SQL-like language that any user can execute. They don't have the same privileges over what they can read, but any user can execute it. So I didn't look into it, but I think it would be really interesting to see if we can do any kind of sandbox escape to full-fledged SQL, or maybe in the syntax parser or in the interpreter, anywhere like that. I think would be a really good attack surface to hit. But yeah, this was my talk. Thank you for being here. Thank you for listening. You can find me on Twitter and on email at the contacts listed. And yeah, that was about it.
Thank you so much, Alex. We appreciate it. That was super detailed and insightful. And I think that it's so important to talk about positive examples and positive experiences in the industry. I think that it really helps to see how a process like this can work, how a process of vulnerability disclosure can work when, everyone kind of puts their best foot forward. So thank you for this. And we won't be taking any questions now, simply because Paul's waiting to share his presentation as well. It was great having you here, and we hope that you'll stick around for the next day as well.
Yep, thank you.